This is a user tutorial for the segmilling.com grindability modeling system that will demonstrate how to add laboratory test work to an existing project. As a user, you should have been set up by your administrator to have read-write access to the project in order for you to enter information. On the home page of your project, there's a button for test work. We will click that, and we'll see that there is currently no testing added to this project. We will start by adding samples. The structure of the grindability test work that's loaded into the program, you will group the tests under a program where the program is usually going to be the laboratory name or a date or something that will group together a bunch of related tests. Then for each sample, you will identify the sample by a name, and then you can identify a bunch of other optional parameters like what's the lithology of the sample, which zone of the deposit did the sample come from, and so on. And then once you have the samples defined, you can then assign the laboratory test results, such as the ball mill work index, the rod mill work index, drop weight results like A times B, other tests like the sag grindability index or the bond abrasion index. So we will create an example new program, and this will be the University of British Columbia testing from 2017. These other fields you see are all optional. We're just going to leave them blank for the moment. So we've created a program. Now we've got 3 samples that we're going to add to the program. And the way that we add the samples is by using a spreadsheet. So you click this example spreadsheet, and the example spreadsheet will pop up. We're going to enter on the Samples tab. These column headers are already preloaded into the template. We're just going to add 3 samples here by the names of the samples. Now each test is going to come on some sort of a standard test sheet like this. So this is the ball mill work index test for, in this case, it's the geomet number 4 sample. And the information that we need for the test program, so here's the tab, I should move that up there. This is the tab for the ball mill work index, WIBM. So here's the name of the sample. Make that a little bit smaller. We'll fit that in there. So the name of the sample, that's the name that it's identified on the test sheet. The closing size that we ran the test at, so we can see that right here. This was a 212 micron closing size. So this closing, this is always in microns. Never, ever, ever, never enter mesh here. This must be in microns. The feed size, 80% passing size in microns. So we read that from the test sheet right there. And the P80 size, again, we read that from the test sheet right there. The grams per revolution, so this will be the average of the last 3 iterations of the test, the last 3 cycles. So that's right there, 1.184. And then the ball mill work index is always going to be in metric units. So we're not going to be ever entering the short ton units or long ton units for work index. Only ever enter the metric units. And then the last of the laboratory results is we want the fraction of the feed that is already passing the closing size. So again, you go back up to here. Here's the closing size. Here's the amount passing the closing size in the feed. So we're going to enter that into this cell. Now, if this is a modified ball mill test, so a modified ball mill test would be, for example, one that is run for 1 cycle or 3 cycles instead of for the standard 5 to 7 cycles. You can put a 1 here to identify that this is a non-standard test. This one is a standard test, so we give it a 0. Synthetic data, sometimes we want to enter an average number or some other number that was generated in a way that didn't come from a test. So if this was synthetic data, you would flag it with a 1, and that allows you to sort out of the database the real tests from the synthetic test numbers. This is a real test, so we're going to give it a synthetic value of 0. Comment, this is an optional field you can enter if you desire. The calculation double checks the work index that you've entered. Usually you're within 0.1. There's going to be some round off error in, for example, the F80 or the P80. And then there's 2 other numbers here which are of interest to the modeling that I'm not going to describe in this video, but are calculated from these test results. So to start off, we're going to enter the sample. We're going to create the sample. These are the fields that you can enter into a new sample. And you'll see that these field names correspond to the field names that are already entered into the Testwork template. Now, for our example, we really only care about the name, so I'm only going to copy that column. All the rest of this would be blank, so there wouldn't be anything there anyway. You copy and paste that out of the spreadsheet, and you'll be asked to confirm that the system has correctly parsed the data that you've entered, so that is correct. We're going to continue. So we now have 3 samples configured for this program, and we're going to enter the test data associated with this ball mill test. So we've already got the spreadsheet is set up. So we're going to click the Add Testwork button. The type of the test we're going to add is a work index for ball milling, WIBM. You can optionally choose to associate this test with a laboratory. We're not going to do that. This is an optional entry. And again, we see a cut and paste field here with the column headers that this particular test is expecting. And those column headers match what we see in the Testwork template already configured. So I could take this block of data, copy it, and paste it into the data block. The system will parse it and give you back what it understands you to have entered for checking. One thing to watch out is that it's very sensitive. You must have the decimal as a point and not as a comma. You put a comma in here, or if you have a feed size that has comma at the thousands separator, that will confuse the system. So don't include a 1,000 separator. Use a point as your decimal place. We continue, and there, it's now entered a ball mill work index. We can check to see that the data is in here. If there is actually a typo, we can go in and we can edit the information in this field and commit a change if we need to commit a change. Now we have some more data to enter into the system, so we're going to close that. So the new information we're going to enter, we have 2 samples. We have a belt 1 and a belt 2. Each of these has been run at a different closing size, but these are all the same sample. So we're going to duplicate the sample name so that the system knows that these are all actually of the same sample. And then I've already entered all of the information we need into this form. I'm going to set this to be a mod BWI of 0 and a synthetic of 0. Copy that down. And then we're able to enter all of this information in one go with add WIBM. We'll just leave the laboratory blank, and we will paste the information in. Now notice that the titles and things might be a little out of place. Don't worry about that. If you've copied and pasted directly out of the spreadsheet, the system will figure out how these things are supposed to line up. And again, check that it's correctly lined things up in this verification screen. And if it looks good, you just press continue. Once data is entered, you can start to do some quality control checks on it. So first thing is we'll just check and make sure that it's entered the data. You can see that the system gives us the average of the work index for all of the one sample that we've entered. So we entered 3 or 4 results for a sample. It's going to give us the average ball mill result for that sample. We can also look at this test work comparison where we look at what happens with the ball mill work index as a function of, for example, the P80 size of the test. So here's our samples plotted against the P80. These are useful tests to make sure that the data entry has gone correctly. And if you see like this one point, this is that sample that's not from the feed belt. This is that geomet sample. So that's fine. And we can also look at the ball mill work index and the 11B value. This is a useful quality control check. So you have this cloud of data where the system expects to see samples, and you can see that these samples are actually quite hard, but they do extend along where the cloud of 11B data expects samples to be. So this sample has passed the quality control check, other than the fact that it's extremely hard. So this concludes our summary tutorial on how to enter ball mill work index data or laboratory test work data into the sagmilling.com system.